Section 1.3 is on distance and midpoints. First thing we're going to take a look at is distance on a number line. So here we have a number line, and we have 2 points on it. This one's labeled P, and this one is labeled Q. And x1 and x2 would be like numbers, so maybe like a -7 and a +3. So PQ, remember PQ without a line over the top means the length of segment PQ is equal to the absolute value of x1 minus x2, or the absolute value of x2 minus x1. So basically, just subtract the two numbers in either order and take the absolute value of it. And if you'll recall from Algebra 1, absolute value basically refers to distance, but the cool thing it does is it makes a number positive. Distance cannot be negative, so we have to make it positive. The other thing about distance on a number line is you don't actually have to calculate it. As long as they're labeled, you can just count. So how far is it from P to Q? Now, distance in the coordinate plane is a little more complicated. Actually, anytime you have a horizontal line or a vertical line on the coordinate plane, you can just count to find the length of that. But if it's slanty, anything like this, you need to use the distance formula. So here we have point P, which has coordinates x1, y1, and point Q, which has coordinates x2, y2, and this is how the distance is defined. So D is often what we use for distance. The distance between the 2 points is the length of segment PQ, which is equal to the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. And this is actually based on the Pythagorean theorem. You remember a squared plus b squared equals c squared. So if you kind of drew this into a right triangle, okay, this would be your A, this would be your B, and this would be your C. Basically what you're doing is finding the length of segment A by subtracting your x's and squaring them, finding the length of B here by subtracting your y's and squaring them, and then remember when you add those you get c squared, because this length squared plus this length squared equals c squared, and then we take the square root of it to get c all by itself. So you really need to memorize this formula. This is called the distance formula. So let's give it a try here. Find the distance between points A, which is at 4, 9, and B, which is at 2, -3. And if you need to, remember when we first learned slope, we did this to help us out a little bit. Feel free to go ahead and do that. If you need to, the first couple times you use the distance formula. So the distance formula is going to be the length of segment AB, which is the square root of x2 minus x1 squared plus y2 minus y1 squared, and then take the square root of the whole thing. So let's just plug in the numbers that we have. So the square root of 2 minus 4, oops, squared plus -3 minus 9 squared, okay, which is equal to the square root of -2 squared plus -12 squared, and the square root of -2 squared is 4. Square root of -2 squared is 4. -12 squared is 144. So the length is the square root of 148. And just as a quick little algebra review, let's go ahead and simplify that radical. So when I factor tree that, I get 2 and 74. And 74 turns into 2 and 37. So these guys can buddy up and go on the outside. So this is the same as 2 square root of 37. So the length of that segment is 2 square root of 37 units long. Definition of midpoint. M is the midpoint of segment AB if and only if segment AM is congruent to segment MB, or the length of AM is equal to the length of MB. Let me back up here. So you probably thought I spelled if wrong here. IFF. This is if and only if. And we saw that in the last couple sections. I believe it was in the last section, where it means that it can go either way. So if M is the midpoint of AB, then AM is congruent to MB. Or I could say if AM is congruent to MB, then M is the midpoint of AB. So IFF is just a shortcut way of writing if and only if. So let's take a look at this definition. So M is the midpoint, so it's right in the middle of segment AB, and that means that the length of segment AM, or segment AM, is congruent to segment MB, or that their lengths are equal to each other. So here's segment AB, M is right in the middle, and the reason I know it's in the middle is not because it looks like it is, but because of these little marks right here. Those little hash marks tell me that AM is the same length as MB. So M is the midpoint of AB. AB. Now the midpoint formula on the number line is very easy. Again, here we have a line, AB, with points A, M, and B on it, and x1 is the coordinate for point A, x2 is the coordinate for point B, and basically we just average them. So to find the coordinates for M, I do x1 plus x2, and then divide that by 2. So it's just the average of x1 and x2. Or if you're on a number line, a vertical or a horizontal distance, you can just kind of count and just kind of hopscotch in towards the center. Now the midpoint formula in the coordinate plane is going to be a little more complicated because this is a slanty line and you just can't count this. So here I have point P with coordinate x1, y1, point Q with coordinate x2, y2, and it's very similar to the formula we had for the number line. I'm going to take the average of the x's, so x1 plus x2 divided by 2, and then the average of the y's, y1 plus y2 divided by 2. And this is in ordered pairs. So this expression right here, x1 plus x2 over 2, is going to give me the x-coordinate of point M, which is the midpoint, and y1 plus y2 over 2 is going to give me the y-coordinate of point M, my midpoint. It's basically the average of the x's and the average of the y's. So let's use this and try an example here. Find the midpoint of segment AB, given that A is 8, negative 6, and B is negative 14, 12. So again, if you would like to label these, go ahead and do that. And my formula, so we often use M for midpoint. You don't always have to, but you can. So remember the formula is x1 plus x2 over 2. That's the x-coordinate of my midpoint. And y1 plus y2 over 2. That's the y-coordinate of my midpoint. So let's plug in the numbers. So I'll have 8 plus negative 14 over 2, and negative 6 plus 12 over 2. That's going to give me a negative 6 over 2 and a positive 6 over 2, or for my final answer, negative 3, 3. And be sure you do write it as an ordered pair, because basically what you're finding is the x-coordinate of the midpoint and the y-coordinate of the midpoint. Okay, this problem says find the coordinates of point D if E at negative 6, 4 is the midpoint of segment DF, with F being at negative 5, negative 3. So I'm going to go ahead and draw a picture, and it doesn't have to be real precise, but I know that E is the midpoint of DF, and that's the main thing I need to do here. So there's D, there's F, and E is the midpoint, and I'm going to designate that by putting a couple little slashes here on DE and EF. And I'm going to label what I know. Well, I actually don't know what D is. That's what I have to find. So I'm going to label that XY. And then E is negative 6, 4. And F is negative 5, negative 3. So I can't really use the midpoint formula as it's written, can I? Because I know the midpoint, and I know one end point, but I don't know the other end point. So I can still use the midpoint formula. So the midpoint is, and actually I'm going to go ahead and label these. So this will be like my x1, y1. This will be my x2, y2. Okay? So my midpoint is equal to x1 plus x2 over 2, and y1 plus y2 over 2. Now my midpoint, I actually have that. That's the point negative 6, 4. And that's going to be equal to, well, I don't know what x1 is, but I know that x2 is negative 5, so that's going to be x minus 5 over 2, because this is my x1, I've called x, my x2 I've called negative 5, or is a negative 5, and then my y1 is just my y, and I need to add to that my y2, which is negative 3 over 2. Okay, now here's kind of the tricky part here. This right here is the x of the midpoint, but so too is this. So those are both expressions for the x of the midpoint. Here's the y of my midpoint, is 4, but then this over here is also the y of the midpoint. So from that, I know that negative 6 has to be equal to x minus 5 over 2, and 4 has to be equal to y minus 3 over 2. So I'm just going to write two equations. So negative 6 equals x minus 5 over 2, and 4 is equal to y minus 3 over 2. And now what I need to do is just solve each of those equations, the first one for x, the second one for y, and that will give me the coordinates of point D. So multiplying both sides by 2, and then adding 5 to both sides, my x is equal to negative 7, and here multiplying both sides by 2, and adding 3 to both sides, my y is equal to 11. So point D is the point negative 7, 11. Okay, and one last problem here. Find the length of PR if Q is the midpoint of segment PR, with the length of PR being represented by 14x plus 2, and the length of QR is 6 minus 3x. So let's start by drawing a diagram here. Do it one down a little bit so I can label things. So Q is the midpoint of PR, and I'm going to note that with little slashes on there. And I know that PR is 14x plus 2, and I know that QR is 6 minus 3x. So I need to find the length of PR, but in order to do that I need to find x first. So remembering from the last section, our little formula for the betweenness of points says that the length of PQ plus the length of QR is equal to the length of PR. So this first length of the first segment plus the length of the second segment equals the length of the whole segment. Now, I don't have an expression for PQ, but I do know that because Q is the midpoint, I do know that PQ is the same length as QR. Because Q is the midpoint, PQ and QR have the same length. So actually what I can do is I can take QR and substitute it into here for PQ. If PQ and QR are the same thing, I could write this as QR plus QR equals PR, because they're both the same thing. Now I can solve this because I know that QR is 6 minus 3x plus another 6 minus 3x, and that's equal to 14x plus 2. Okay, so basically what I did, let me go back and, since PQ is equal to QR, wherever I see a PQ, I can substitute in a QR. Okay, so let's see, let's clean things up a little bit here. 12 minus 6x equals 14x plus 2. Adding 6x to both sides. and subtracting 2 on each side, and then dividing both sides by 20. I don't need to write that out. X is equal to 1/2. X is equal to 10 over 20, or 1/2. Now, am I done? No. Go back and read the problem again. It says find PR. Okay, so what I need to do is substitute in 1/2 for X. So 14 times 1/2 plus 2, or the length of PR is going to be 7 plus 2, or 9. So in this section we looked at the distance formula and the midpoint formula, and you'll need to have both of those memorized. The midpoint's a little bit easier, and if you need to remember the distance formula, just remember that it's based on the Pythagorean theorem.